Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Asma binti Khairul Zaman. My matric number is DN220084. So I am from Group 5. So here our project is about coordinated motion control for sequential electro-pneumatic system. Let me introduce our group members, which are from two different courses, BND 25603 and BND 32103. So our group has 4 members, which is Kuhan Raj, me, Nur Asma binti Khairul Zaman, Muhammad Amir Imran, and Muhammad Ifwat. For objective, we have conducted the project with 3 objectives. First, this project objective is to develop operational skills program testing and troubleshooting the error in PLC programming by using CX programmer software to solve the engineering problems. Second is to design, simulate, and troubleshoot an electro-pneumatic control circuit for an engineering problem in direct actuation method which safely sequences 3 cylinders. And lastly is to demonstrate and troubleshooting the error in electro-pneumatic circuit by using flexible pneumatic software to solve the engineering problems. So for the design statement, our group trying to design engineering industry system by using 3 piston rod, which is 2 piston are double acting cylinder and other one is single acting cylinder with spring return. So here is our engineering problem statement. The blocks are to be transferred from a gravity feed mechanism to the clamping station before proceeding to the processing station. Cylinder 1A push the blocks out to the gravity feed mechanism and clamps them after 10 seconds. The cylinder 2A will stamp the part and retract once again. The piston rod of cylinder 1A may only return when the piston rod of cylinder 2A has reached the retracted end position. Cylinder 3A will transport the stamp block to the processing station before retracting to the end position. This process keeps repeating for 3 times. That's all from me.
Assalamualaikum dan selamat sejahtera. Okey, saya Muhammad Ifwat bin Shariful Yamani. Saya akan terangkan tentang experimental setup. So, macam kita boleh nampak kat sini, kita menggunakan PLC CP1E trainer kit. So, yang saya boleh tunjuk, saya dah labelkan iaitu yang ni switch on. Yang korang-korang boleh nampak switch on. Lepas tu dia punya ni, kat sini input. Lepas tu output, dia ada output. So kalau macam kita boleh nampak dekat CP1E tu ada tempat cocok USB port. Lepas tu kita ada supply 24 volt. Okay, next. So, saya akan cerita lebih untuk pasal circuit kami. So kita menggunakan double acting cylinder ada 2. Lepas tu single acting cylinder 1. Lepas tu limit switch kita menggunakan 5. And then kita gunakan solenoid 5 two-way double solenoid valve, kita gunakan 2. Lepas tu 3 two-way solenoid valve kita gunakan 1. And kita ada 2 push button yang kita gunakan di dalam pneumatic punya barang. So macam korang boleh nampak, kabel-kabel tu semua kita cocok dekat CP1E trainer kit. So kalau macam kita boleh nampak kat sini, bila silinder yang pertama tu keluar, sensor biji 2 akan detect and silinder nombor 2 tu akan keluar juga and biji 4 akan detect. Bila biji 4 detect, yang silinder 2 tu akan masuk dahulu and lepas tu baru silinder yang pertama. Lepas 2 tu dah masuk, silinder yang ketiga iaitu single acting silinder tu akan keluar sekali je. Maknanya dia keluar dia keluar sekali, faham? Lepas tu dia ke belakang balik. Macam tu cara dia berfungsi lah. So kita orang cocok. So kalau kita boleh nampak kat sini, kita punya solenoid valve tu MB1, yang atas tu kita cocok ke input, yang bawah tu kita cocok ke ground. So macam tu semua solenoid, semua lebih kurang macam tu. yang atas akan masuk ke input dekat dalam PLC trainer kit ni. Manakala untuk limit switch pun lebih kurang juga. Dia akan satu akan ke BG ni, dia menggunakan input sebab ada sensor. Kalau kat dalam PLC dia sensor di input, so kita punya address tu input. So satu satu connection tu akan pergi ke input, manakala satu lagi connection tu akan tentukan sama ada normally close ataupun normally open. So yang tu kita akan cocok kepada uh, negatif punya supply. So itu saja daripada saya. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Amir Imran. Hari ini saya akan menerangkan mengenai litar yang digunakan untuk projek ini. Okay, pertama sekali ialah litar pneumatik. Okay, dalam litar ini kami menggunakan 3 silinder, iaitu 2 double acting silinder dan 1 single acting silinder. Okay, cara litar ini berfungsi adalah, pertama sekali kita akan menekan butang SF1 dan dia akan mengaktifkan timer. Okay, selepas 10 saat dia akan mengaktifkan silinder 1 untuk bergerak ke hadapan, dan seterusnya dia akan menekan sensor BG2. Selepas BG2 aktif, dia akan mengaktifkan silinder kedua untuk bergerak, untuk maju ke hadapan, dan sensor keempat akan diaktifkan. Selepas sensor keempat diaktifkan, dia akan menyebabkan kedua-dua silinder, iaitu silinder 1 dan silinder 2 untuk kembali ke kedudukan asal mereka, dan silinder ketiga akan bergerak ke hadapan dan akan menekan sensor kelima. Sensor kelima itu akan merekod ke dalam counter untuk menunjukkan sudah berapa banyak kitaran litar ini berlangsung. Selepas counter tersebut selesai mengira kitaran litar tersebut, dia akan mematikan keseluruhan litar, dan pengguna perlu menekan button SF2 untuk mereset semula kitaran litar tersebut. Seterusnya adalah litar PLC. Di dalam litar ini kami menggunakan fungsi set reset, timer, diff D dan juga counter. Cara litar ini berfungsi adalah seperti, pertama sekali apabila push button 1 ditekan, dia akan mengaktifkan set function yang akan berfungsi sebagai latching kepada litar ini. Seterusnya dia akan mengaktifkan timer 1 selama 10 saat, dan selepas 10 saat dia akan mengaktifkan MB1. Dia akan menyebabkan piston pertama kami bergerak ke hadapan, dan seterusnya dia akan mengaktifkan BG2. BG2 tersebut akan mengaktifkan MB3 yang akan menyebabkan piston ketiga kami bergerak ke hadapan. Selepas MB3 bergerak ke hadapan, MB1 dan juga MB2 akan bergerak ke belakang, dan MB5 akan aktif menyebabkan piston ketiga bergerak ke hadapan. Selepas piston ketiga bergerak, dia akan mengaktifkan BG5. BG5 tersebut akan mengaktifkan function diff D, di mana dia akan aktif selepas BG5 dimatikan. Diff D akan mengaktifkan counter yang akan merekod berapa banyak cycle litar tersebut sudah berjalan. Selepas counter habis mengira kitaran litar, di mana kami telah setkan counter tersebut sebanyak 4 kali, dia akan mengaktifkan switch di reset, di fungsi reset yang akan mematikan keseluruhan litar. Dan begitulah cara kami menghasilkan projek pneumatik ini. Sekian dari saya. Terima kasih.
Hi, my name is Kohan Raj and my matrix number is CN210335. So for this presentation, I will talk about discussion and also conclusion. So for the discussion, what is all about a discussion is? Discussion is what we're going to discuss in a report or a slide on what we observe, what we get while doing the project in the laboratory. So usually this is where the place will discuss about what are the problems we faced, and yeah, all the things has a problem and we need to troubleshoot it. So we have to present what we found, what problem we found, and how we troubleshoot the problem and have a solution for the problem. So I'll discuss on the next slide about what problem we found and what is the solution we also find for that. All right. So the first challenges is improper wiring. Okay. PLC installation from CX programmer into CP1E CP1E trainer kit. So normally we will design in FluidSim software and also the CX programmer software. After that, we'll install them into the CP1E trainer kit, where after we have to assemble all the components we used. Okay. What are the components we use is double acting cylinder, limit switches, five two-way double solenoid valves, and three two-way solenoid valves. So as a real-time issue, circuit program designed in FluidSim software and CX programmer software does not working as expected. So what we design and how we execute it, how we install it, and when we run, it doesn't occur properly as we wanted. So we troubleshoot them. So okay, and one thing is CX programmer software has their own features inside, like simulation mode. We can observe whenever we press on the real time buttons, we can observe in the CX programmer software which button are we pressing and what are the ways or what are the cycle is going on now. Okay, and the challenges inability to observe output conditions when push button is pressed or when limit switches detect cylinder movement. Like I said just now, CX programmer has their own features inside where we can detect what are the cycles going on, what is the condition is now, the real time program or real time laboratory is going on now. Okay, so we troubleshoot them. Okay, successful visualizations of circuit program in real time and effective use of simulation mode for debugging and analysis. So the next slide I will talk about what are the solution, what is the problem and what is the solution we find. Okay, all right. So this is the problem where the connection, okay, the improper wiring, the connection from the com until the negative port in 24 volt DC power supply in the trainer kit. Again, so suppose there must be only have one connection from external input, which is the COM in the external input connectors, have to be connected with the negative port at the 24 volt DC power supply. But there is two. So when we just change it, it works well. So I'll explain more about it on the next slide. So yeah, has a solution for the problem. Ground wiring fault in the common connection. So that's the problem. Investigation. Detect an issue with the ground wire from external input connectors. Okay. So connection clarification. Realize COM should have only one connection with the negative port at the 24 VDC power supply in the training kit. Okay, so we have investigated what is the problem now, and now we have the solution also, so we're going to execute the solution now. So yeah, now for this part, the solution, how we execute the solution, how to fix the problem. Okay, so wiring adjustment. Remove one wire from the previous two wire connection to correct the ground wiring. Okay, next one is comprehensive check. Ensure all wiring connections were reviewed to prevent future issues. So we have to check, so that after checking only we can install back the coding and then we can execute. Because in case there's other problem, then it will waste the time and delay the process. Okay, so as a result, successful resolution of the problem, circuit now functions according to the designed program. Okay, so next I will present about the conclusion of this whole project. Oh yeah, before I start presenting my conclusion, so this is the photo after troubleshooting. Sorry, after we fixed, okay, we changed the wiring to make sure there's only one wire connected, and yeah, this is the one. All right, so this is the last part of this presentation of this IDP project with the team of Form that successfully completed a motion control project for an electropneumatic system. Improved skills in PLC programming, circuit design, pneumatic troubleshooting using CX programmer, and also fluid pneumatic software. Okay. Work together to tackle a pneumatic challenges. We work together no matter what are problems. We never give up. So these are the lessons we learned. Not only we just learn about the softwares and how to use them, the components or what. We also learn as a team how we have to work on as a team, how to solve a problem as a team, and no matter what, we should not have given up. Even even our project does not start and finish. It's we have a lot of things we have gone through. Some circuits didn't work, and the components, how to do the programming, lot of things I've gone through. Okay, so we also carefully programmed circuit for smooth operation. So before we doing the circuit, we think twice. We design the motion sequence diagram, the displacement sequence diagram, so that it'll be a little bit easy for us to do the programming. All right, so the next part of the conclusion. We have tested and stimulated the system under different conditions. Like in FluidSim, pneumatic software is different and CX programmer is different. So we have tried both of them. So we have also choose the best component to ensure accurate motions. We just never use simple components. We use a perfect and correct components, and our teammates, there's one teammate who is really master in choosing the components. Okay, so we used a simple diagram for guidance and future experiments. Okay, so thanks to the team and tools used, not only our team have given us support, but also the tools who listen to us as programmed and does not give any external problems, right? So considering improvements for future projects and exploring advanced automation technologies. So as a team, we still believe in future we able to do wonders or also can create things like this, because we are one team with four of them have gone through a lot of things and we know each other. So thank you so much for Madam Chesumaya for giving us this opportunity to get and to learn more about PLC programming and also about us. So thank you so much. That's all from me. Tekan.